Good evening, everybody. Roy Gunson, a degree in physics from the University of Bradford, Master of Science in Engineering. Later worked as an IT manager for Sheffield Hallam University at Salter Lane, which was the art college, before it was knocked down. After working for over 30 years at Hallam, Roy has now settled down to a busier life as retired. A prolific speaker for Probus, UA3 and WI groups, as well as astronomical societies. So please put your hands together and welcome Roy Gunson without a T.
Right, I'm going to share the screen. And there we are. That should be the front page. 3 short talks put together fairly hastily. I'd half done the job because we thought a previous speaker was going to not turn up on us. So I'd got it in a sort of a back pocket, but it needed tidying up quite a bit. And so this has been worked on since Tuesday. I've not timed it. I hope it will last at least a little bit of time. I've got 3 talks. The optical devices of Christiaan Huygens. These are the voyages of the USS Manhole and Benjamin Banekker. What I tend to do is I'm going to give one of the talks and we'll have a little break at the end of each talk for you to pass comment, blow raspberries, throw cabbages, whatever you want to do. So the first talk is the optical devices of Christiaan Huygens. Many of us know about Christiaan Huygens, born in 1629, died 1696. He's noted for first identifying the rings of Saturn, because before that they were thought to be handles. He also discovered Titan. He invented the pendulum clock, apparently, and he did a lot of investigative work on optics, diffraction and reflection and that sort of thing, in line with what later Newton would have done. So Huygens became interested in telescopes in the middle of the 1650s, 1651, 1652, and he got a telescope maker in Germany to make him one, probably on the same lines that the scope that Galileo had, and he was very disappointed. It was poor, the light gathering power was rubbish, and it didn't magnify very well. So he taught himself how to grind and polish lenses with his brother Constantine. And as a result, he designed and made a grinding machine to do its own lens grinding and lens polishing. And on the screen there, you can see basically a diagram of Christiaan Huygens' grinding machine. I haven't a clue how it works. It looks very Heath Robinson-ish, but apparently it did a good job of grinding lenses. It's probably more famous in terms of astronomy for actually determining what the Saturn had rings, and he detailed actually how the rings would change as Saturn orbited the sun. I mean, they'd only observed Saturn for a few years, so they'd not seen Saturn go around the sun in any detail whatsoever. But he managed to work out what the rings would look like at various times in the future. And you can see there part of his book he wrote about his observations of Saturn and how he worked out how the rings progressed as Saturn orbited the sun. Also on there is notes regarding his discovery of the moon of Titan. And it's interesting, the telescope he used for this had an objective lens that was given in the book as 10 Rhineland feet. And apparently a lot of countries in Europe, England included, because we were part of Europe then, had different types of feet. A Rhineland foot was about 12 1/3 inches long. It was a bit longer than an English foot. It had 12 inches to the foot. But in his book, he says that it was 10 Rhineland feet long. Eyepiece had a focal length of 3 Rhineland inches. And it gave a magnification of around about 40, 45. So that telescope doesn't exist anymore. But actually, if you go to Utrecht and the museum in Utrecht, they actually have the object lens for his telescope that he discovered Titan with. Scratched on the lens in diamond, with a diamond, is the date of manufacture of the lens, which is February the 3rd, 1655. And he's also scratched on there in Latin. I'm not going to pronounce the Latin because I can't speak Latin, but it translates as "they brought the distant stars closer to our eyes." With this telescope, he was also the first to observe and make a drawing of the region of Syrtis Major on Mars. And he managed to calculate that the Martian day was about 24.5 hours long. He was only about 7 minutes out. He's also known to have done the first known drawing of the Orion Nebula and also the trapezium stars. So I'm not quite sure how big that objective, it looks to be about maybe 2-3 inches. It's very hard, there's no scale to it. So it's very difficult to see actually how big the lens is. Just for comparison, this is one of my photographs of Saturn. I took this, it's actually 10 years ago. But I'm quite proud of that because I've got four of the moons nicely spaced out, including Titan, which Huygens was the discoverer of. One of his other things is, in those days, long focal lengths were preferred in telescopes because it reduced the chromatic aberration. And Christiaan Huygens published designs for tubeless aerial telescopes. Now, whether he was actually the inventor of these is not quite clear. They started to spring up all over Europe at that time. But their invention has been attributed to him and his brother Constantin. In the Huygens aerial telescope, the objective was mounted inside a short iron tube. You can see it up at the top here. I'll move the mouse up here. Mounted on a ball joint on top of an adjustable mast. So it goes up and down, this swivels side to side, and it's connected to the eyepiece, which is mounted in another short tube on sort of a tripod stand, and it's connected with a piece of string or a taut rope. The separation was about 200 feet. Apparently he was on good terms with his neighbour because the objective lens and the mast were in his garden, but to observe he had to go through a little gate and go into his neighbour's garden with his eyepiece on a stand to look through the telescope. Now, I have great difficulty sometimes in pointing my telescope exactly at the right spot. I mean, me and Paul have been up to the observatory and we've taken photographs of galaxies, and we've set the coordinates in and the telescopes, and we started taking a photograph and we've got half the galaxy because it's at the bottom half of the screen or the top half, and we have to fiddle and adjust. I mean, how the heck they managed to keep things in focus and keep it pointed in the right direction especially with the sky moving. So they've got to follow the rotation of the sky. I have no idea. I mean, I'm full of admiration for this. Apparently, they could use a lantern. You see the lantern alongside the drawing here, and they used to shine it at the object lens up here and look at the reflection and get that reflection over the object they were looking for, a bit like our modern red dot finder. I just find that incredulous. I just do. The longest aerial telescope ever recorded was about 600 feet in focal length, and again, I'm gobsmacked on that one. Here's another one. This was actually used by Cassini in the Paris Observatory in 1684, and he managed to find the moon's Dione and Tethys with it. And again, I mean, it looks virtually impossible to use to me. And in 1722, James Bradley measured the diameter of Venus with an aerial telescope with a focal length of 212 feet. The development of the reflecting telescope and the achromatic lens, the double lens, consigned these telescopes to sort of the pages of astronomical history, and thankfully we don't have to use these anymore. Well, the thing Huygens invented, or is noted for inventing, was a type of eyepiece. The very early eyepiece, this is the eyepiece that Galileo had, which was simply a double concave lens. It's sometimes called a negative lens, and that presents an erect image in the telescope. It's got a very limited field of view. It's used today in fairly cheap kids' telescopes, you would say, some binoculars and opera glasses. Very quickly, they started to use a simple convex lens. Johannes Kepler makes a note of this in his 1611 book on astronomy, the dioptris. It gives you a better magnification, a wider field of view, and it allows you can put a graticule behind the eyepiece, so you can measure distances between objects that you observe. But Huygens developed a two-lens eyepiece. It's still in use today. It's usually the type of eyepiece that's packaged with some of the bottom end of the Skywatcher range that's around today, and the Newtonians. He invented this in 1662. Two plano convex lenses. It's supposed to give a wider field of view, reduced aberration, and as I say, it is still used today, but we do have better eyepieces that you can spend money on that give a really better fields of view than this. But that's his eyepiece. The other thing, because he was interested in optics, he is credited with being the inventor of the magic lantern or projector. It's possible that the idea for this came from the fact that a Dutch inventor, Cornelius Drebbel, developed a type of camera obscura with a lens, and Christiaan Huygens' brother bought one of these, and it's thought that Huygens and his brother developed the lantern from this concept. Earliest reference we find is from Huygens' manuscript of 1659, and he lists his inventions, and one of those is La Lanterne Magique. He describes the workings of his magic lantern provided with 3 lenses, and he intended it to amuse his children at home. And a friend of Huygens, a Dutch Jesuit, Andreas Staquet, actually built his own version of Huygens' magic lantern and gave the first performances for audiences. And that's really how the invention got out. The sketch you see there on the right hand side is in one of Huygens' notebooks from 1664. Huygens wasn't very proud of this invention. He was ashamed because very quickly it got into the public domain, and swindlers were using it to frighten people and extract money on the street. His father, Christiaan Huygens' father, was actually part of the French court of Louis XIV, and at the king's request, the king wanted a magic lantern. So in a letter to his brother, he explains, "I felt ashamed that in this way it will only come from me. People are kind enough to feign admiration, but later on they will ridicule it, and not without reason." So unable to get out of the request from the king, he sends the lantern to his father, but asks his brother to sabotage it by removing one of the two lenses that are close to each other, so that only two lenses remain, as there are three in total. As for assistance, he pretended to have forgotten how to construct his lantern, saying, "Having removed the lenses long ago, I cannot remember what kind they were." So he wasn't very happy with his invention. On the other side of that slide, you can see pictures of skeletons, and this is the type of thing that the unscrupulous people were doing. They were doing like horror shows and changing slides very quickly. It's sort of like an early horror movie because they got the skeletons to move on the side of walls and inside buildings in order to frighten people and pretend they were ghosts. So that's the end of part one. I'm going to stop screen sharing there and we can have a little chat. How are we going? Okay.
Okay, we're all back. So it's the usual routine. I'd prefer a hands up electronically. Otherwise, wave at me. So, Andy Devey, question.
Hi, Roy. Can you hear me okay? Just a quickie. Has anybody in modern times tried to recreate these long focal length telescopes? Because it would be quite an interesting experiment.
Not that I'm aware. I mean, as I say, I'm gobsmacked that they actually got them to work and actually discover moons of Saturn and what have you with them. I mean, 200 feet apart, and it's halfway up a flagpole. I mean, I have problem aligning a short tube Cassiopeia at times, let alone that.
It's just that with auto align and things like that and electronics, nowadays it would be very easy to line up. It'd just be interesting to see how they perform.
Yeah, yeah. I mean, they did it mainly because the lenses were very shallow. They were very slightly curved, which were easier to make. So it got around a lot of the chromatic aberration that was occurring with the quality of the lenses. So the bigger they could make it, the less distortion and aberration they got.
Okay, thank you.
It did make a nice experiment.
Yeah.
Yeah. Tony Morris.
Hi everyone. Roy, we spoke to Alan Chapman about this subject some time ago, and I'm sure he said somebody was going to try and make a smaller version of an aerial telescope, but never heard what happened.
No.
But what Alan also said was it was difficult to make short focal length eyepieces. So you had to have the long focal lengths of your main objective, because that to get any reasonable magnification, because your eyepieces were 3, 4, 5, 6 a foot in focal length anyway. So it was a combination of things that they had to overcome.
I just find it so strange. I mean, that, you know, the idea that he's got this object lens up a pole in his garden, and he's got to trot to his neighbour's garden with the eyepiece on a tripod. And the idea of the sort of the early version of the red dot finder with the lantern shining in the lens, so he can guide it to what he's looking at.
I think Alan also spoke about the difficulties getting good glass.
Yeah,
and I'm sure he spoke about the best glass was from Venice at the time. So it wasn't easy just getting good homogeneous glass to make your lenses anyway.
So I mean, it's interesting what they did to develop in telescope. And of course, when the mirror Newtonian started and the Gregorian and what have you, I mean, it all changed. I mean, there was sort of a move over to reflecting telescopes very, very quickly.
Venice is still renowned for its glassmaking, and they're famous for a particular pattern, the millefilori, 1,000 folds or 1,000 flowers, even today. So yeah, Venice is the place. There's an island off the main city, Murano. Roy, the lens grinding machine.
Yeah.
Everything I've learnt about lenses or grinding lenses, the objective is to be as random as possible. With a totally mechanical device in those days, you know, it seems to be counterintuitive.
I don't know. I mean, as I say, I've no idea how it works. There's just that illustration of Huygens' lens grinding machine. Who knows? He was happy with it. He made his lenses.
Yeah,
I think you'll find, Paul, I think you'll find that the errors in the mechanical linkages and the gearing would be random enough to produce the spherical surfaces.
Right. Okay. Yeah. Especially in early days of clockmaking and things, because that definitely looked like an escarpment mechanism that seemed to be hanging perpendicular to the main table.
Well, Huygens was into clockmaking. I mean, he is associated with inventing the pendulum clock. So that was another one of his strings to his bow, if you like. Okay.
I'm having a quick look round for any other comments, questions. Anybody want to add anything into that? And I can't see anybody. Do you want to? Do you want to?
I've got to part 2.
So if you want to share your screen.
There you are, end of part 1, as I was before. There we are, 50 pence in. Right. Second talk, entitled is These Are the Voyages of the USS Manhole Cover. I think some of you have heard this before. It was an article in Messenger about 5 or 6 years ago. So we're looking at Operation Plumb Bob, which was a series of nuclear tests performed by the United States in the mid-1950s. It was probably the biggest, longest and most controversial test series in the United States. You can actually go today and visit the Nevada test site. It's 65 miles north of Las Vegas, and they offer public tours. They're often quite fully booked, but you're not allowed to take in cameras, binoculars, cell phones, or pick up any rocks for souvenirs. If you go on the internet, you can actually see photographs of people in Las Vegas on rooftop hotels in swimming pools, looking out over the desert, and in the distance there's sort of a mushroom cloud. I'm not sure whether those photographs are real or faked, but you know, it's only 65 miles away from Las Vegas, so they may be able to have seen the mushroom cloud. So 1956, this chap, Dr. Robert Brownlee, he was a physicist, also an astronomer, but he was working for the Los Alamos National Laboratory in New Mexico. And he was asked to examine whether nuclear detonations could be conducted underground. And they were given the name Project Thunderwell. And he was faced with the problem of containing these explosions. So he put the bomb at the bottom of a vertical tunnel in the Nevada desert. And the first test was known as Pascal A, July the 26th, 1957. And the bomb was lowered down a 500-foot borehole. That first test, the yield apparently turned out to be 50,000 times greater than they anticipated, creating a jet of fire that shot hundreds of feet into the sky. The test director, Robert Campbell, wrote, "The first thing we did at Los Alamos, it was in a hole called Pascal A. It was 500 feet deep in a cased hole. We put the bomb at the bottom of it and we didn't stem it. So we fired it. It was the biggest damn Roman candle you ever saw. It was beautiful, a big blue glow in the sky. Everybody who was in the area, we all jumped in our cars and drove like crazy, not counting who was there or who came out of the area." Basically, they scared themselves to death. So it was decided to try and contain the blast. You can see a picture of what it was. I mean, basically, you got a 500-foot hole, 4 foot wide, bomb at the bottom. So Pascal B, August the 27th, 1957. Again, Brownlee put a bomb at the bottom of the 500-foot vertical tunnel in the Nevada desert and sealed the top with a 4-inch thick armor steel plate weighing about 900 kilograms. And it was welded over the bar hole to contain the nuclear blast. Brownlee predicted it wouldn't work to stop the explosion, so they added a 2-ton concrete collimator plug above the bomb. And there's the concrete bomb. Shaft diameter is 4 feet in diameter. He knew the lid would be blown off, but he didn't know exactly how fast. So has Jules Verne come to life? From the Earth to the Moon. So, August the 27th, 3:35 p.m, Pascal B was detonated and the fireball reached into the blue Nevada sky. As a lad, I can remember putting a banger in a tin can on bonfire night. Don't half make a noise, and the tin can shoots into the air with the force of the explosion. Not quite the same scale as this. One of the results of this, it gave scientists a boost for the idea of Project Orion. The concrete plug would have been vaporized instantly, increasing the pressure in the shaft. The high-speed cameras caught the giant manhole cover as it began its flight into history. Based upon his calculations and the evidence from the cameras, Brownlee estimated the steel plate was traveling at a velocity up to 6 times that needed to escape Earth's gravity. "We never found it, it was gone," was a comment. Here's a bit of maths I got from another book regarding the explosion. Maximum velocity achieved by expanding gas is given by that equation. C is the speed of sound in the gas. You put some estimates in, and they can come up with a speed of 56 kilometers per second. Brownlee himself, with his more detailed computations, came up with a figure of 65 kilometers per second. Pascal B, where it detonated, the blast went straight up the test shaft, launching the cap into the atmosphere. 65 kilometers per second, it's about 150,000 miles per hour. it's quite possible the compression heating caused the cap to vaporize as it went through the atmosphere. But you never know, it might have got through there. There was a high-speed camera which took 1 frame per millisecond, and it was focused on the borehole. After the detonation, the plate appeared in only 1 frame. Dr. Brownlee joked that the best estimate of the cover speed from the photographic evidence was that it was going like a bat. In 2015, Dr. Brownlee added, "I've no idea what happened to the cap, but I always assumed it was probably vaporized before it went into space." However, there is this conversation. Dr. Brownlee, when he described his results to Bill Ogle, who was one of the directors of the test, Ogle, "What time does the shock wave arrive at the top of the pipe?" Brownlee, 31 milliseconds. Ogle, "What happens?" "The shock reflects back down the hole, but the pressures and temperature are such that the welded cap is bound to come off the hole." "How fast does it go?" Brownlee said, "Basically, my calculations are irrelevant. They're only valid in speaking of a shock reflection." Ogle pressed him and said, "How fast did it go?" "These numbers are meaningless. I only have a vacuum above the cap, no air, no gravity, no real material strength in the iron cap. Effectively, the cap is just loose, traveling through meaningless space." But having pressed, he says, "Oh, it's 6 times the escape velocity of the Earth." If the manhole cover made it into space, it was traveling fast enough to escape the solar system too. And rough calculations have indicated that it went in the direction of the constellation of Bootes, slightly curved with the gravitational pull of the sun. And it's now, if it's there, currently somewhere between 600 and 700 AU out from the sun, about 4 light days. Robert Brownlee died only 3 years ago, aged 94. He studied astronomy and physics. During the war, he was a navigator on the B-29 bombers in the Pacific War, Pacific. And later life, when he stopped exploding nuclear bombs, he retired and became an eclipse chaser. He wrote a book of his biography. It's there, Dr. Robert Brownlee, Atomic Testing in the Nuclear Age. I've tried to find it. You can't get it on Kindle or Amazon or any book supplier. A suggested publisher is Vestige Press of Colorado, but they're out of business. And it's advertised on Robert Brownlee's webpage, but that's not been updated since 2015, and there's no active links on it. So if you can find a copy of the book, if you're interested, good luck. And that is the end of the second tale.
Okay.
There you go.
I was just looking. I was astonished at that picture of the test site and the number of craters.
Yeah.
That dotted it, and you now understand why carbon dating is no longer any use, or hasn't been any use for the last, or measuring anything in the last 80 years. So, yeah, absolutely amazing how many dots there were around it.
I suspect there are testing other things rather than nuclear bombs with those craters, but
there were an awful lot of big craters in there.
Yeah.
but there you go. So Robert Brownlee, what did he do besides make these two big holes? Oh, before we go on to that, was there an access tunnel down the side where they installed the bomb?
I have no idea. I have no other information on it at all.
It's just, I was just thinking, you know, you got to feel sorry for the poor technician who's been lowered down on top of that bomb and, you know, sitting there in a hole with an atomic bomb. But there you go.
Yeah. Brownlee, as far as I can work out, after working for the government on the test site, he dabbled in a bit of teaching, but he retired fairly early, started writing and lecturing as a freelance, but also got involved with stained glass, and he learned how to play church organs. So he gave recitals on these large church organs in various places around the world, and amused himself with stained glass, creating stained glass windows.
Okay, there you go. Okay, anybody got any questions?
Yeah, Roy?
Yeah?
What was the name of the book again?
It's Atomic Testing in the Nuclear Age.
Okay.
The Mind and Life of Dr. Robert Brownlee, and he's the author, Dr. Robert R. Brownlee.
I may have got a PDF.
There you go.
I'll look and search and get back.
Well, I had a quick look this afternoon, and as I say, his website is dead, and there's no links working, and the alleged publisher no longer exists. They're out of business. So I checked some of these second-hand book sites on the internet, and I couldn't find anything at all.
Okay, Andy Devey.
Can you hear me okay?
Yep.
Okay. If that's going upwards at 6 times escape velocity, surely it would make a bright streak similar to a meteor coming, or a meteorite coming all the way, wouldn't it?
I would expect so. It was probably disguised by the flash of the bomb as well at the same time.
Yeah.
But as I said, according to the records, they got one image of it flying off the top on the cameras, which was taking I forget what the time interval was now, but from that they could work out a bottom limit of velocity, but even that was greater than escape velocity. The question is whether it actually made it, whether it was heavy enough to get completely through the atmosphere before it completely vaporized. It was a big lump of iron, so there's a good chance.
Tony Morris.
Just more information about the atomic testing. A lot of the testing was done in secret, so the American people didn't know. But the Kodak film company in Rochester, New York, noticed that quite a few of their batches of films were being damaged, and they didn't know why. And in the end, it was the Kodak company that realized that it was radiation from the Nevada test site that was damaging their films. So the Department of Energy, I think who it was doing some of this testing, actually used to inform Kodak when they were going to do the tests, so Kodak could take precautions to protect their films.
Right.
But the people of the United States were never told, but Kodak were. And there's a really good YouTube video about it. And it goes into the details of the radiation and the clouds and what, effectively what particles Kodak discovered, which were damaging their films.
Well, that is fascinating, actually. So, yeah, I will dig that out. Thanks for that, Tony. I'm looking for questions. Nobody? No. So, Roy, if we go back to
part 3, end of part 2. Part 3 is this chap, Benjamin Banekker. Was born in 1731, November the 9th, he died in 1806, October 1806, and he was a free African American, which was quite unusual at that time. His mother and father were Mary and Robert Banneker, according to the records, who were freed slaves. And apparently they both died in about 1759. But they owned a small farm. They were landowners, which again was slightly unusual. In 1737, he's named at the age of 6 on the deed of the family small farm near Baltimore. And it's thought that Banneker's parents sent him to a school where he learned reading, writing, arithmetic, fairly basic. This school may have been a nearby Quaker school. The Quakers were very keen on equality, not only of the sexes, but also of the races. So they would have taken in a student of a black race, African American. But apart from this basic learning, it's thought he had no formal education and was largely self-taught. And he wouldn't really become noticed in the field of mathematics and astronomy until he was in his 50s. One of the first things that is notable about him, that when he was about 21, 1753, he constructed what's considered to be the first clock in America, the first American clock. Before that, the clocks were imported from Europe, and it was made entirely of wood. Banneker apparently had become fascinated with the workings of an imported pocket watch to a friend, and he took it apart to study its workings. I mean, what a brave friend. You know, your mate says, "Oh, can I take your watch and take it to bits?" You know, and watches wouldn't have been cheap items in 1753. Banneker then carved his clock out of wood to make basically a working clock that lasted some 40 years. It struck every hour, on the hour, and people actually took notice, and he got a slight amount of fame for building this clock. It obviously doesn't exist anymore. That's a replica idea of what it may have looked like. But not a lot is known about Benjamin in the intervening years up to about the 1780s. He remained unmarried and lived alone. He obviously read books and was largely self-taught whilst running the farm, especially after his parents died. In the 1770s, a family called the Ellicotts built some mills around Maryland and had a big farm that was adjoining Banneker's land. Banneker was befriended by the family, and it's suspected that the head of the Ellicott family, Andrew Ellicott, lent Benjamin some books from which he was able to study mathematics, astronomy and geometry. And Andrew Ellicott also worked for the government as a surveyor. And in 1788, Banneker used the knowledge he had gained from the family and from the books he'd borrowed to accurately predict the time of a partial solar eclipse in 1790 and an annular solar eclipse that would occur in 1791, passing over Maryland. And again, this gave him some note in local newspapers. I mean, Banneker would have been almost 60 years of age by now. So that's the two eclipses were November the 6th, 1790, and April the 3rd, 1791. The first one, 1790, was partial, and the April the 3rd was an annular eclipse that occurred over Maryland and the district where Banneker's farm was. Relationship with the Ellicotts became even more beneficial, and he was invited to help Andrew Ellicott to survey the new federal city that would become Washington, D.C. So he helped lay out the map for where Washington DC would become. According to the newspapers, there was a lot of upset at the time of having a black man do this. According to what they call the Georgetown Weekly Ledger, Ellicott was attended by Benjamin Banekker, an Ethiopian, whose abilities as a surveyor and an astronomer clearly prove that Mr. Jefferson's concluding that that race of men were void of mental endowments, and that was without foundation. Thomas Jefferson wasn't very kind to African Americans. He was famously known for espousing freedom and equality, but he questioned the ability of African Americans to have the same intelligence as the white race. Jefferson wrote many articles about freedom and equality and questioning slavery, but he had upwards of about 700 slaves through his lifetime. In 1791, August 1791, he penned a letter to the Secretary of State denouncing Jefferson's hypocrisy about the freedom of all men. And this letter that Banneker wrote to the Secretary of State is in the Library of Congress. Jefferson actually responded to the letter and said lines on the line, "Nobody wishes more ardently to see a good system commenced for raising the conditions of blacks to what it ought to be." And because of the letter, Jefferson actually recommended Banneker for this employment as assistant surveyor for Washington, DC. Actually, when Banneker died, Jefferson recanted his praise and said basically the Ellicotts had actually pumped him up and promoted him, but he wasn't very good. So there was a bit of hypocrisy there from Jefferson on that one. But one of the things that Banneker actually did later on was actually from 1791, he published a series of annual almanacs on astronomy and politics. Also quite a bit of political work on the abolition of slavery. And he continued to write letters to Jefferson over Jefferson's owning of slaves. So there's a bit of dispute going from the pair of them. Apparently, I mean, he didn't have a telescope or anything, but Banneker used to go out in the night, and it says he would wrap himself in a great cloak and lie under a pear tree and meditate on the revolutions of the heavenly bodies. He would remain there throughout the night and take to his bed at dawn. So you're looking at a 60-year-old man who's starting to come into prominence. This is part of his almanac. This is the Empheramis for 1792. It contains the motion of the sun and the moon, the true places and aspects of the planets, the rising and setting of the sun, the rising and setting of the south in place and age of the moon, lunations, conjunctions, eclipses, judgment of the weather, festival and other remarkable days, days for holding the Supreme and Circuit Courts of the United States, printed and sold by William Goddard and James Angel at their printing office in Market Street. And I've got the sharing bit of it, but a complete and accurate Empheramis for the year 1792, calculated by a sable descendant of Africa, who by this specimen of ingenuity evinces to demonstration that mental powers and endowments are not the exclusive excellence of white people, but that the rays of science may alike illuminate the minds of men of every clime, however they may differ in the colour of their skin, particularly those whom tyrant custom have taught us to depreciate as a race inferior in intellectual capacity. They flatter themselves that a philanthropic public in this enlightened era will be induced to give their patronage and support to this work. So it's quite a bit of politics going on in his book. So he writes eclipses for the year 1792. There'll be 2 eclipses. The first will be visible on the 22nd day of March in the afternoon. And he notes where it is. This will be a central eclipse on the meridian between the islands of Cocos and the Galapagos in the Pacific Ocean. The second will be in the 16th day of September, invisible. So we can't see it. It's not. And he names and characters of the planets. The sun is the nature of a fixed star. Mercury moves around the sun in 87 days. It's the nearest planet for it. So he describes the planets. These are the tables of tides and the moon. Times of high water in Chesapeake Bay are very uncertain. It depends much upon the circumstances. He puts in little bits and pieces like anchors of ships invented in AD 578, needles first made in London by a Negro from space in the reign of Queen Mary, but he's dying without teaching the art, and it was lost until 1566. So he makes all sorts of little claims. Here is sort of tables of, here's the moon, there's a new moon. So I think this is December. I can't see the top of the screen on here, but this is the phase in days. So here's new moon, start of the moon again. It south rises, the sun rises and sets. Where the moon is in position, the constellation, say you got Aries, Gemini, Taurus, and he'll even predict the weather. So it's going to be clear and windy, flying clouds, rain, clear and cold. I mean, he's doing a better job than Paul Hudson there. So he wrote these books for a number of years, and unfortunately he took to drink. After selling much of his home tight to the Ellicotts, he died in his log cabin 9 years later on October the 19th, 1806, age 74. It says he got chronic alcoholism, which worsened as he aged, and it might have contributed to his death. There's a replica of his cabin in what's called the Benjamin Banekker Historical Park, and there is a Benjamin Banekker Museum nearby. It was reported that his original shack was burnt to the ground with most of his books and papers on the day of his funeral. Whether that was accidental or not is some subject of debate. And that's the end of my little talks for tonight. I hope you've enjoyed them. I've put them together. I hope they were interesting. I'm going to stop the share again. And off we go.
Okay, thanks, Roy. It's absolutely fascinating, isn't it, once you start delving away. And it's so sad that even after, what are we on now? 200 years plus.
Yeah.
We seem to be still making heavy weather of this.
There's still some of those attitudes around, unfortunately.
Yep. Yes, lots of work there still to be done. Okay, so we're looking for questions. Nobody.
I've bamboozled them all.
You've silenced everybody, Roy. Look at that. Well, oh no, Trevor Worrell.
Hi, Roy. Very interesting three-part of that. It was just a point really on that last one. I noticed that he classified his planets and stars, and he referred to Uranus as the Georgian star, having been discovered the year before. Just thought it was quite interesting that the word had spread so rapidly. You know, once the planet had been discovered in those early days, I guess there wasn't much you know, communication apart from maybe boats taking the mail across.
Yeah, I mean, surprising how quick things went.
Just thought it's interesting to see it there in black and white.
Thank you, Trevor.
No, thank you.
Andy Davey.
Hi, Roy. 3 excellent talks. Enjoyed all 3 of them. Just a couple of observations from the last one. When you're looking at the printing, the letter S, they used an F, but without the horizontal line, didn't they? If it was mid-word, but on occasions at the front of the word, if it wasn't a capital letter as well.
Yeah. It makes it difficult when I'm doing these talks to try and read it.
Yeah. And the only other observation is, it's the first time I've heard of somebody being buried and yet his house being cremated.
Yeah.
Couldn't resist that one, I'm sorry.
It is. It's odd though that the fact that on the day of his funeral it was burnt down. It looks like nobody wanted. Somebody didn't want his legacy to last, as it were.
Yeah.
Because basically all his books and journals were lost. There's only a few that was actually rescued by the Ellicotts, that they had them. Apparently the clock that he built was burnt alongside his cottage.
Yes, he was obviously an embarrassment to certain sections of the community. But yes, as I said, still a lot of hard work to be done in that direction.
If you go on the internet, they actually got a lot more about his dispute with Thomas Jefferson on there, and the series of letters that he wrote. I didn't want to put it in because you tend to get bogged down in a bit of detail. But if you're interested, there was quite a feud between them in terms of comments. And after he died, Thomas Jefferson basically recanted what he said. He sort of got rid of all the praise and said that basically he was pumped up by the Ellicotts and he wasn't actually that bright.
Peter Lloyd.
Yes, thank you, Roy. 3 very interesting talks. Just a small point I picked up on in that last talk. I was fascinated by the tables that he produced. And I was thinking in 17, whatever it was, there must have been an enormous amount of work involved in producing those tables.
Yeah.
I don't know whether slide rules existed, but calculators certainly didn't.
I mean, considering he was self-taught, he probably, I mean, there was probably some information around, but he would have to adjust it for his own location in Maryland to make it work. I mean, he got fame over the eclipse apparently because, in a sense, the professionals, such as they were in those days, had predicted a particular time and date, and he changed the time, and he was actually more accurate than the so-called professionals at sort of the emerging universities in America at the time. So that's why he got noted. I mean, the amazing thing is he only really started when he was about 58 years of age. He built the clock when he was in his 20s, but obviously has spent the intervening time working on the farm, looking after the farm, and just studying in his spare time.
Yeah.
Okay, ladies and gents, I think we should thank Roy again for 3 excellent talks and for stepping in at such short notice. So Roy, thank you very much.